This is the most detailed motorcycle breakdown on the entire internet, from the engine, to the clutch, to the transmission. We're going to explain it all in one go. The engine is the source of all power. There are two main ways to start it. One is using the kickstarter, and the other is using the starter motor. Let's talk about the kickstarter first. The kickstart mechanism is actually quite simple. At its end is a helical spline, which is connected to a gear. When you step down on the kickstart lever, the helical spline forces the gear to slide and mesh with a gear on the transmission. If you continue pushing the lever down, the power transfers to the clutch gear, then travels through the clutch to the crankshaft, ultimately delivering that initial rotational force to the engine, allowing it to start up. The starter motor is essentially a small DC motor. The moment you turn the key and hit the ignition, the starter motor begins to spin. Its gear transfers power through a reduction gear to the starter ring gear. The ring gear then transfers this power to the crankshaft. And just like that, the engine starts spinning. Once the engine is running, the starter motor cuts power and stops working. Next, let's take a closer look at how the engine actually works. When the engine starts, the valve rocker arm first opens the intake valve. The air-fuel mixture then flows through the valve into the cylinder. When the piston reaches the very bottom, the rocker arm closes the intake valve. The piston then moves upward, rapidly compressing the air-fuel mixture. When the piston reaches the top, the spark plug ignites the mixture. The resulting explosion rapidly forces the piston back down. Then, the rocker arm opens the exhaust valve. As the piston moves back up, it pushes all the exhaust gases out. This entire cycle repeats over and over again, allowing the engine to generate continuous power. This power then travels to the motorcycle's clutch. Let's see exactly how the clutch connects to the engine. This is the engine's crankshaft. It spins along with the engine. At the end of the crankshaft is a small primary gear. It meshes with the large gear on the clutch basket, driving the clutch to spin. Now, the clutch sits on the exact same axis as the transmission's input shaft, so the rotation of the clutch then drives the transmission gears. But the clutch does more than just transfer power. It can also disconnect the power. When the power is disconnected, the rider can smoothly shift gears without stalling the engine. So, how exactly does it disconnect the engine's power? This is the clutch basket. It spins constantly with the crankshaft gear. But here's the catch. It is not directly geared to the transmission. So, when the basket spins, it doesn't spin the transmission gears. The other major component of the clutch is the inner hub. It sits right inside the clutch basket, but it is directly connected to the transmission's input shaft, meaning it spins together with the transmission. The problem is, the inner hub and the clutch basket spin completely independently of each other. They cannot transfer power on their own. To connect them, we need to add a connector between them. Once we do that, the engine's power can finally flow to the transmission. If we remove this connector, the power to the transmission is cut off once again. But there's an issue here. When we just inserted the connector, both the basket and the inner hub were totally stationary, so it was easy to slide it right in. But in reality, the basket and the hub are spinning at completely different speeds. How do we solve this? We can split the connector into two parts. One part features tabs that mesh with the clutch basket, allowing it to spin with the basket, while also being able to slide side to side like this. The other part has teeth that mesh with the inner hub. Now, when the outer basket spins, the part meshed with the inner hub won't spin with it. But if we squeeze these two parts tightly together, it creates immense friction between them. When the friction is strong enough, the two parts lock up and spin together as one. If you want to disconnect the power, you simply pull them apart. This is exactly how a real clutch works, though the actual structure is far more complex. In real-world applications, to maximize the contact area, the clutch uses multiple friction plates. These plates mesh with the outer basket. They are separated by metal steel plates, which mesh with the inner hub. These friction and steel plates are stacked alternately inside the basket and hub. On the very outside sits the clutch pressure plate. This plate is held down by heavy-duty clutch springs. To make this easier to understand, let's look at a cross-section of the clutch. You can see the springs are secured to studs with bolts. This setup allows the pressure plate to move back and forth under an external force. So, where does this external force come from? The answer is the motorcycle's clutch lever. When you squeeze the clutch lever, the clutch cable pulls the actuator arm down here. The rotation of this arm pushes a long pushrod back and forth. This pushrod runs straight through the engine and presses against the pressure plate, pushing the plate out and lifting the pressure off the stack, allowing the clutch to engage and disengage the power smoothly. After passing through the clutch, the power heads to the transmission. Let's break down exactly how the gearbox works. These are the transmission's input and output shafts. Each shaft features splined sections and smooth sections. This is a spline gear. It locks onto the splined sections of the shaft, allowing it to slide side to side while spinning with the shaft. This silver gear has no internal splines, so it sits on the smooth section of the shaft. It cannot slide side to side, and it simply freewheels around the shaft when they are meshed together. If the left gear spins, the right gear will spin with it. But because the right gear is freewheeling, the output shaft it sits on doesn't spin at all. To make the output shaft spin, we can add another spline gear next to it and lock it to the silver gear using these gear dogs. Now, when the silver gear spins, it drives the adjacent spline gear. And since that gear is locked to the splines, the output shaft spins with it. This transmission has 6 gears. Every spline gear is paired with a freewheeling silver gear. Right now, no gears are locked together, meaning the motorcycle is currently in neutral. If we want to shift into first gear, we just slide the number 5 spline gear to the right. Once it locks in, the output shaft spins at first gear speed. To shift into second gear, we first slide the number 5 gear back to its original position, then slide the number 6 gear to the left to lock it. Now, the output shaft spins at second gear speed. The rest of the gears work the exact same way. The rider simply presses down or lifts up on the shifter to move these gears. This happens because the other end of the shift lever is connected to a shift pawl. When you step on or lift the shifter, the pawl rotates this shift star, and the shift star is directly connected to the shift drum. The shift drum has specially designed grooves carved into it. These are the shift forks. At the bottom of each fork is a guide pin. These pins sit perfectly inside the grooves on the shift drum, and the spline gears sit right inside the arms of the shift forks. As the shift drum rotates, the grooves force the guide pins to slide, moving the shift forks side to side. And just like that, the transmission shifts gears. But when shifting, as you move from one gear to the next, the previous gear must disengage into neutral first, before the next gear can lock in. If the drum stops halfway, you lose all power. That's why we need this shift star. The shift star is made up of a series of peaks and valleys. Below it sits a spring-loaded detent arm with a roller. When the roller sits on a peak, the gearbox is technically in neutral. When it snaps into a valley, the bike is in gear, but the roller can't rest on a peak. The spring tension forces it to slide right down into the next valley. This prevents the transmission from getting stuck in a false neutral between gears. But this creates a new problem. When the rider actually wants to find neutral, they wouldn't be able to. To fix this, engineers simply shave down one of the peaks on the star, creating a dedicated half notch for true neutral. This allows the detent roller to rest perfectly in this spot, and the motorcycle smoothly drops into neutral. If you want to keep upshifting, you just click the shifter up once more, and the power is instantly reconnected. After the transmission adjusts the speed, the power finally arrives at the output sprocket on the shaft. This sprocket connects to the rear wheel via a drive chain, and just like that, the power is delivered to the rear tire, and the motorcycle is ready to ride.